For each supervisor, we recorded the gender associated with the assigned file and the promotion decision. Using the results of the study, summarized here, we would like to evaluate if females are unfairly discriminated against in promotion decisions. So you can see from the results, there were 24 male files, 24 female files. Among the 24 male files, 21 would have been promoted, 3 not. From the female files, 14 would have been promoted, 10 not. So in this study, a smaller proportion of females are promoted than males. Again, females would be 14 out of 24, which comes out to 58%. For males, 21 out of 24, which is about 87.5%. But it is unclear whether this difference provides convincing evidence that females are unfairly discriminated against. Again, if you think back to the earlier example, 51 heads, 49 tails, that's probably a random chance. I have 90 heads, 10 tails, that's probably an effect. So what we're looking for here is, could this have happened by random chance, or is this really discrimination? So statisticians are sometimes called upon to evaluate the strength of evidence. When looking at the rates of promotion for males and females in this study, why might we be tempted to immediately conclude that females are being discriminated against? So going back, you see 21 males would have been promoted, only 14 females. So there are more males that would have been promoted. So 21 of the 24 males were promoted compared to 14 of the 24 females. Empirically, males were more likely to be promoted. On the other hand, why might we be tempted to conclude that there is no discrimination? So in this case, sample size is relatively small. The differences between males and females could just be random chance. So the question is, which is the more likely explanation? Random chance or discrimination? Well, to answer that, we need to start getting some numbers. So the large difference in promotion rates, the 58% for the females versus 87.5% for the males, suggests there might be discrimination against women in promotion decisions. However, we can't really be sure yet if the observed difference represents discrimination or just random chance. Generally, there is always a bit of fluctuation in sample data, and we wouldn't expect the sample proportions to be exactly equal, even if there is absolutely no discrimination at all in the promotion decisions. So the table below shows there are 7 fewer promotions in the female group than in the male group. That difference is 7 out of 24, or 29.2%. This observed difference between the two proportions is called the point estimate of the true effect. So the point estimate is the sample value that we're going to use to answer this question of whether it's random chance or discrimination. In this case, the point estimate is that there's a difference of 7 out of 24, so 7/24, so 29.2%. Males are 29.2% more likely than females to be promoted. So this point estimate of the difference is large, but the sample size is small, so making unclear if this observed difference represents discrimination or whether it is simply due to chance.